It's time now to look at one of the capabilities of WebDriver that we sometimes leave towards the end of a project, and we shouldn't, because we should bring in new browsers, different browsers, as we start testing. Because as we introduce new browsers into our testing, our tests require some massaging. They may require different synchronization. They may require different startup routines. So it's worth trying to do that at the start of the project. I'm introducing different browsers at the end because I want you to have the basics of WebDriver first before we do this. But when you implement it in the real world, start thinking about different browsers early in the project. In WebDriver, you've seen the FirefoxDriver, and we typically use that because it's built in. You don't have to download anything extra to use the FirefoxDriver. The HtmlUnitDriver again you've seen, and that also is built in. That's just a jar that gets bundled with it. We use it to do this. The ChromeDriver is a separate .exe that you download. Then you have to set up various parameters to get it working. The Opera driver is also a separate .exe, but because it's available through Maven, when we use it we would just be adding it to the POM, and then we'll have access to it. The IEDriver again is a separate .exe, and obviously this one only works on Windows. The remote driver is currently built in. What that requires is a server to connect to. So when we first show you that, I'm going to be connecting off to Saucelabs, and then later on I'll show you how to use Selenium Grid and connect to that through the remote driver. And then there are various mobile drivers in the Safari driver. And to be honest, in the real world, I typically use the Firefox driver and the Chrome driver. We use the IEDriver when organizations say we must see this system working on IE. So then we'll use the IEDriver and we'll set it up on some sort of grid somewhere. And I sometimes use the Opera driver simply because I use Opera at home. I think it's a really good browser. I really love the development tools that are built in. It starts up fast, the driver's quite nice. There are some issues with it. It doesn't handle certain parts of the API. But all these browsers, all these drivers, introduce new complexity into your tests. Some of them will respond with exceptions, some of them won't. Some of them will require you to add synchronization points where others don't. Some of them will have startup routine problems. Some of them you have to call with different flags. So I'm basically going to cover an introduction to each of these browsers to get you started. When you start using them in earnest on your projects, that is when you will start to understand the complexities associated, or the nuances associated with each of these browsers. So we're going to get you started so that you can do it. And I think I'll also show you a kind of driver manager class that I use in the code base for this, and we'll have a look at a couple of other ones as well to show you different ways of starting up these browsers. So when we're working with WebDrivers, we can tell WebDriver exactly where the path is using the property variables that we're going to be setting up before we start the test and before we start the ChromeDriver. Here I'm telling WebDriver exactly where the ChromeDriver is by setting the WebDriver.Chrome.Driver property. The other way to do this, or another way to do this, is to set up the ChromeDriver in the path, so that in the test I don't have to set up the property variables. I simply instantiate the driver. So that's what we're going to look at now. So with this particular test, if I run this, I do not have the ChromeDriver on the path, so the test will fail. And there we go. It's saying the path to the driver executable must be set with this property. Please do these things. So what I'm going to do now is I'm going to close the IDE down and add the ChromeDriver path to my system path variable. And the reason I'm closing the IDE down is that the IDE, when it starts up, picks up the current system path and uses that. Any command line that you have when you start it up takes the current system path and uses that. Even if you change the path, the current IDE and current command line windows will use the old path. So we have to close them down when we change the path. So I'm going to close this down. Now what I'm going to do is I have the WebDrivers in a folder here, C:/WebDrivers. And here's ChromeDriver, and there's ChromeDriver.exe. Now I know that ChromeDriver.exe is not in the path, If I get a command line up and I type ChromeDriver.exe in the path, it says it doesn't recognize it. So I need to set up the path. There's a couple of ways I can do this. In Windows, I can right click on this PC or my computer, choose properties. It will pick up the control panel. If you're on Windows 10, you can do Command X, go straight up to System. Then it gives you the system variables. There's a whole bunch of tools that will help you do this. It's pretty simple. So once we've got the system information up or the properties, we're going to change the settings. And in the Advanced tab, we want the environment variables. Then I'm going to select the path, edit it, and I'm just going to add a new line in here. So first of all, it's going to go back to where the driver is. I'm going to copy the path. Then in the edit environment variable, I'll do new and copy the path in. Do OK. And that's it. The path is now set up. If I go back to get a command line, so there's ChromeDriver.exe started from the command line when I'm in a different folder. That means it's on the path. Go up a bit. ChromeDriver.exe. Doesn't matter which path I'm on, the command line's picked it up. So now if we start IntelliJ again, if I run this test now, remember this test does not tell WebDriver where the Chrome driver is. So it started up, ChromeDriver, went to the page, ran the test. So as a summary, what we're doing is we're adding to the path the folder that the Chrome driver is in. We're adding it to the path without the final backslash or anything like that, just c:/WebDriver/ChromeDriver, wherever your driver is. And this will work with FirefoxDriver, IE, whichever drivers you're using. This is how you add them in the path on Windows. So we have two ways of working with Firefox. Versions before, version 45, we just use the Firefox driver, which is built into WebDriver. Remember, we can download Firefox version 45 from the Mozilla Extended Support page. For versions of Firefox above 46, we can't use that method anymore. We have to use the MarionetteDriver. And the MarionetteDriver is a separate download, which we get from the Marionette project page. Now hopefully the documentation will be up to date, but essentially we download it, we unarchive it. Supposedly we can add it to the path, but I haven't been able to get that work yet. So I change the properties, the Gecko property, so that WebDriver knows where to find it. The Marionette is the most up-to-date version of the Firefox driver, and that is the way that we're going to be using Firefox going forward. And eventually, when we do Firefox driver in WebDriver, it will default to and use the Marionette driver. But at the moment, we have to use the Marionette driver separately. So we can only use the Firefox driver at the moment for versions below 45 or 45 and below, and we use the Marionette driver for versions above 45, i.e. 46 and onwards. So this is the Marionette driver. Marionette driver was introduced back in 2012, but we really only have to start using it from Firefox 46 onwards, and that's in April 2016. The Marionette driver, when I'm making this video, is still being worked on. So it's not fully finished yet. So whilst the document says we can add it to the path and use it, I haven't been able to get that to work. So I use Marionette setting it up through the system properties. So you can see here I have a before class method, which is setting up the various properties for the Marionette driver so that I can just instantiate a Marionette driver directly, because everything that we need to set up is already set up in the before class. Now I would always set this up in a driver class anyway, and if you look in the code for the driver.java, you'll see that I've done that in there, and Marionette driver is handled in there so that I don't really ever have to worry about this again. But when we use this in production,
we'll make decisions about how best to configure the location for the MarionetteDriver and how best for our test to pick that up. It could be systems properties, it could be hard-coded in the driver, it could be environment variables. There's a whole bunch of different ways of doing that. But essentially, like any other driver, we set the location, we start the driver, we get things, we use it exactly the same. And MarionetteDriver will improve over time. In theory, it works the same way as the FirefoxDriver, where we create capabilities and pass them into the driver. But again, at this stage, I haven't managed to get the proxy working with Marionette. I'm working with 6.02 of the MarionetteDriver. It may well be working by the time we get used to this, and I'll try and keep the course up to date. But there's really not very much to say about the MarionetteDriver other than we go to the Marionette page, we download the executable, we have it in our tools folder, the same as all the location of all our other drivers. We set the path or the property and we use the driver. I haven't seen any nuances around that yet. And the MarionetteDriver will work in grid as well, like any other remote driver. And then hopefully at some point it will become seamless and it will just become the Firefox driver.
Over the next few slides, I'm going to provide an introduction to the Firefox driver. Even though you've seen it, there are additional functionalities that I'm going to draw out for you. Then, having seen it in slides and examples on the screen here, we're going to dive into the code and have a look. So the Firefox driver is built in. You get it for free when you download Selenium pretty much. It's easy to get started with. For me, it can be slow to start up. You saw that in the videos. I've edited it down. I suspect that's just because of the profile that's built up, and I could probably amend that because I've got too many plugins in there. I could probably stop some of those loading if I really wanted to speed that up. We always have options when we use this, and it's really just a matter of exploration to work out which ones we need. And you've seen the basic way that we start up the Firefox driver. Basically say a driver equals new Firefox driver. Now hopefully you explored with the parameters that can have, and you saw that we have the ability to create a new driver with a profile. The profile is what you have on your machine when you start at Firefox, where the plugins that you have installed are listed in that profile, where the various settings that you've stored are in that profile. And what happens with the Firefox driver is it creates one on the fly for you as you start it up, but we can tell it what to do in that profile. So you've already learned the difference between native events and the JavaScript ones. We can control that through the profile that we pass into FirefoxDriver by doing set enable native events. We can also set different preferences, which are the actual browser preferences. When you look in the help for Firefox, that's the name of it, that's the property in the Firefox, so that we can tell it, we can control the browser. Here I am setting the version of the Firebug preference. Now that doesn't make any sense out of context here, but when we start to add Firebug in as an extension, when I load it in as an extension, that property makes a difference because it stops the default welcome dialog for Firebug coming up if I set the current version. So as you try and add more extensions, or as you try and control Firefox in different ways, you'll start to learn to use the profile. Now the other way that we have of controlling the browser is through capabilities. Capabilities come about because when we're using remote WebDriver, we have to tell the remote WebDriver, I want you to give me a browser that has these capabilities. So I suspect that more and more of the browsers, the drivers, will move over to capabilities as their main control mechanism. Currently, the drivers have different mechanisms. So Chrome has options that you set. Opera has options or preferences, I can't remember exactly which. Firefox has the preferences and in the profile as well as the capabilities. And over each iteration, each release of the drivers, the way that they start up has a tendency to change. Sometimes the capabilities are in there, they're being moved away a little bit. There's now the tendency to start up a service in order to control these. So over time, this startup for each of the drivers will change. So you have to keep on top of that. But really all you're doing is you're looking for a way of starting it up. If you need more control, then you investigate how to get that control over the driver. So understand that we can configure these drivers before we start them up. That's the important thing to learn, because then it's just a matter of investigating how. Pretty much everything that you can control in the browser, you can control before you start it up with WebDriver using properties, preferences, command line arguments, or capabilities. I typically use it for loading plugins. I load the Firebug plugin when I'm wanting to debug my automation. I will send the tests to the browser through a debug proxy to help me see the traffic. That's pretty much all I tend to configure in these things, but and so that's what the examples that you're going to see are built around. But if you have other needs, it's just a matter of identifying how in the browser you control that, then starting up through the various mechanisms that are associated with the driver to get that working. Okay, it's time to drop down into the code now. For each of the drivers, I have some example tests in the code base. Let's look at the Firefox ones. Now, let's start by showing some useful links first. Okay, so we said that you can control the preferences for Firefox. How do you know the preferences? Well, you put about config in the search box, then you see this giant list of preferences. Now the first time you do that, it will say, are you sure this can kill Firefox? You say, yes, I am. And you can change them from within Firefox, but remember, these are things that we can set before we start it up, if we want to. There is some documentation over here on preferential.mozdev.org/preferences. It says it was last updated 2006. I don't know if that's the case or not. Chances are you won't need to amend very many of these, but if you do, these are the sources you go, or do what I do, which is just do a general Google search on how do I make this happen in Firefox, and you'll get some answers back. We also have the Firefox driver documentation on the wiki. This should be useful. This lists some system properties, it lists various other things. I haven't seen that before, but that's good. That's pretty much the code that we're going to be using later on to add Firebug in. I wish I'd known about that before. So let's have a look at some of these tests. Now you have already seen this one. This is the most basic we can do. Some of these I'm not going to run because you already know this. This is the most basic. Create a Firefox driver, allocate it to a variable that has been defined as a WebDriver, do the normal get, then quit. Remember, we have to quit after we create the driver. Now hopefully at some point you did a control P in here, or to look at the parameters that were available to us, and you can see that we've got a profile we can pass in, or we can pass in a set of capabilities that we desire to happen. We can also tell it where to find the binary, although we can set that via various system properties as well if we have to, and we can do the different combinations of these. So let's have a quick look at the profile. So here I'm using the profile to set enable native events on. I create a profile with Firefox profile, and you can see that profile has some methods on it. We can enable native events, we can add extensions, we can set the preferences that we just saw in that about config. And you see the old way of setting the proxy preferences in Firefox was to create a proxy object and then set it in the set proxy preferences. That has now been deprecated in favor of the capabilities. This is what happens with the drivers. Things get deprecated. They change. You have to learn, keep up to date and learn the new way of approaching the drivers. So this really does nothing else except set enable native events, and you've really seen that. So this is slightly newer. This is starting to use the capabilities. So here I am creating the proxy object. I'm setting the basics so that the proxy settings are for the HTTP, FTP, and the secure socket layer. Then I have to create a capabilities object using desired capabilities. Then I set the capability for the proxy type. Then I instantiate a Firefox driver with those capabilities. So in this case, the capabilities are the going through a proxy. And remember, if I needed to, I could add the profile and the capabilities. So let's have a quick look at this. Now on Windows, I normally use Fiddler as my proxy. And the newest version of Fiddler now picks up the normal Firefox traffic, the Opera traffic, pretty much everything else. So I don't really have to set up the proxy in advance if I'm using Fiddler. But sometimes I will start up the proxy from the code. So I will use the browser mod proxy, or I will use one of the other Java proxies to have the tests start up the proxy, monitor the traffic, dump it out to a file, then stop. Under those circumstances, I want to be able to tell the driver to point through a proxy. So that's what we're simulating here. So this proxy, I'm going to be using this driver.proxy value, which is set up as localhost 8080. That's the string that is going to get passed through. And that is the default proxy port that Burp Suite uses. Let me just show you Burp Suite. Burp Suite is a debugging proxy. It's very often used in security testing. I really like Burp Suite because it is cross-platform. It's written in Java, so when I'm working on Linux, I can use Burp Suite, and I'm familiar with it because I can use it on Windows as well. It has two versions, the free version and the paid-for version that has more capabilities. I'll be using the free version here. That has more than enough capability for monitoring the web traffic. I'm also using a slightly older version. That won't make any difference for our purposes here. So I start up Burp Suite from the command line. I'm going to do java-jar burp suite. It's going to complain that I'm using a more up-to-date version of Java than this was tested on. That's fine. So this is Burp Suite. You can see tutorials on the web for how to use Burp Suite if you don't know how to do it or you want to get into this. In fact, I presented a couple on YouTube. You'll probably find those from the EvilTester webs. So in Burp Suite, under proxy, in options, it tells me what port it's listening on. So this is localhost 8080 as you saw. Now I'm just going to put the history tab up here, and this is going to show me the traffic that is coming through Burp Suite. So when I set up this proxy, it's going to point at localhost 8080, which is now Burp Suite. I'm going to set up the capabilities as I want a proxy. Set up like this, please. Then I'm going to start with the Firefox driver using those capabilities. We're going to get this page, then assert the title. So let me run this test. Okay, so that test passed, and you saw the URL come through, and then Firefox will do an update. Now, the thing that always gets me with Firefox updates is that sometimes that can invalidate my tests. It may be missing acceptable, great. Sometimes that can invalidate my tests. Sometimes I need to go and look for a new driver. Sometimes. That's just one of the prices we have to pay for keeping our browsers up to date. If you want a machine that is more controlled, then keep your browsers more controlled, or use the remote WebDriver and connect through into Saucelabs, where they already have machines set up with all these different versions of the browsers, or you can create your own grid system and do that. But typically you'll find out if you're working on your local machine, this will happen. Firefox will update, things will break. You need to try and keep your build machines as stable as possible and your grid as flexible as possible if you want to avoid these kind of interesting interruptions into your work. So you saw that we configured that to use the proxy. Now this next test, what I'm going to be doing in this is setting up an extension. Now you've already seen in all the various other tests when we use Firefox manually that I can inspect element with Firebug. That's one of the things we take for granted. Now I don't know if you noticed, if I run the most basic one here, the I'll put this in debug mode. The browser that is started does not have Firebug installed. So you can see here that the WebDriver plugin that's brought in by WebDriver is there, but there is no inspect with Firebug. There are hardly any other plugins in here. It's a very clean profile. So if I'm in the middle of a test, I want to debug, I've got the built-in inspect element now, which is great. We never had that for a long time. It was very hard to debug. This may give you enough information. This may be more than enough. This may be more than enough when you're debugging tests. Sometimes I still need Firebug because I want to mess around with check the cookies or see some scripts or see what else is going on, what's in the space for Java, what's happened. I want to do more investigation. That's when I need Firebug. And that's what I'm going to be doing in this last test here. I'm doing this the fairly hacky way. I'm basically saying I have the extension stored here in resources. There it is, Firebug 1.10.5. So I'm basically saying here is a path, my current user directory, which when I run the tests will be WebDriver Basics, my code directory. That's what this will expand to. And then I'm basically saying, I want you to look there and then in source./test/resources to find Firebug. That's what this does. This sets up the path for that chain to find this file. Then I say, create a new profile, set the preference for the Firebug current version to 1.10.5. If I do not do that, then Firebug will show the startup page, which now is not that invasive. Now the Firebug startup page is another tab. I think it used to be a dialog. It used to really get in the way of running tests. It doesn't do that anymore. So this is less important, but still a useful thing to do. I will show you what happens if you don't do this. Then we want to add the extension and basically say, here it is. Find this, add that as an extension in the profile so that when Firefox starts, it will load that in. Now we could add whatever extensions we want. We can set whatever preferences we want. If we want any of the Firebug add-ins, then we have to add those as extensions as well. There's not a lot more to say about that, except if you get this path wrong, then this will helpfully throw an exception and say it can't load the extension for you. So let me debug this test. There we go. So now inspect element with Firebug. We've loaded the extension. It is there for us. There you go. Now some people will tell you that you don't want to do that. You don't debug the tests when you're running them. You write unit tests around doing this, yada yada yada. People will tell you a lot of things. Your job is to get something done. You'll do that the easiest way and most efficient way that you can. If you need to add an extension to help you debug your test, then you add an extension to help you debug your tests. If you want an extension that is only there when you're testing, this is how you add it. You do whatever it takes to test that application. So let me just show you what happens if I don't have that preference in. It's not a big deal anymore, but let me just show you this. And it's pretty much how you know that the preferences are being set when the effect that you want doesn't actually happen. Great, so there's our browser and you see an additional tab. And the additional tab is Firebug welcoming us and saying, you know what, there is a new version, because it doesn't know what version we already have installed. So it's basically going, it's the first run, are you using 1.10.5? Great. So that's how you get rid of that warning with that preference. And there's not really a lot more to say about this at the moment. When you need to do additional things, if you need to start up Firefox with JavaScript turned off, you'll be able to figure those things out using the preferences. What's important at the moment is just to understand these mechanisms.
So one of the tricks I've been using when getting ready for WebDriver 3 is using the portable version of Firefox. That way when Firefox is upgrading to a version that isn't compatible with the legacy driver that's in WebDriver and needs to use the MarionetteDriver, given that the MarionetteDriver doesn't have all the functionality that I need yet, what I've been doing is using PortableFirefox and the normal inbuilt Firefox driver. So this is only on Windows. If I go off to the portableapps.com site, you can see that they've got a launcher that you can download. I tend not to use that. What I do is I go straight to apps, I'll do a search for Firefox, and then I can see that there's a Firefox Portable Edition. Now currently that's listing version 48. I don't want version 48 because 48 only supports the MarionetteDriver. Anything that's 47.1 and below, I can use the normal legacy driver. Now I could install the Firefox Extended Support release, but then that would override the version 48 that I already have. So in order to have multiple versions of Firefox, I can have Firefox running on version 48 and use that. But if I go off to the download page, and if I amend the URL to show me the different versions, so really I just want the Portable Apps files and then their Mozilla Firefox Portable Edition. So then I can see that we've got versions of Firefox for a whole bunch of different releases. So that's version 48. Here's the portable version of the extended release version 45.2, and there's version 47.0.1. So if I download that one, then I can choose which language. I download it and it gives me an installer which I run. Now the installer doesn't really install, but it gives you a kind of unzip process. So you can see what I've done here is after I've installed it, put it into C:/WebDrivers Firefox Portable version 47.0.1. So now I can then access that in my code. So here's a little test. What this test does is it's setting up desired capabilities. You can see that I've actually got this ready for Selenium 3. This won't impact anything on Selenium 2.53.1, but I'm basically saying set capability Marionette to false because I want to use the legacy driver. If I set this to true or leave it out, Selenium 3 will default to Marionette. Selenium 2.53.1 will ignore this capability. So I'm just doing that to force the legacy driver when I'm using Selenium 3. When I'm creating the Firefox driver, I tell it which Firefox binary to use. So let's set it to where we just installed it, version 47.0.1, and it's the Firefox Portable. So then I just create the Firefox driver like normal, using a default profile with the capabilities of Marionette. Then it should start up, go to this form, check it, and close it as normal. Let me run this. So there's the Firefox Portable logo coming up. Then we should see Firefox, just like normal. But what that means is I've got Firefox 47.0.1 running for the test there, and my normal Firefox is Firefox 48. I do have support in the driver class for this. So here, if we look at the top, you can see if I give it the name Firefox Portable, it will look for a property Selenium Simplified.Firefox Portable to tell it the path of the Firefox Portable, which means I could install version 46, version 47, and run the tests against those just by changing this property to a different path and setting the driver type to Firefox Portable. So that's pretty much it. That's a little hints and tip for using Firefox Portable or just controlling where you've located the Firefox executable.
Okay, the HtmlUnitDriver is hosted on sourceforge.net, so if you want any documentation around HtmlUnit, go in here and get it. The version that's in Selenium may not be the most up-to-date version on HtmlUnit. You're living with whatever has been bundled with Selenium. There is another up-and-coming headless browser that is going to start taking WebDriver by storm. That's the Phantom.js one. Hopefully the driver for that will be finished fairly soon. Then we will have a kind of native JavaScript browser that we can use that should do screenshots as well. It could be quite interesting. The HtmlUnit is completely code-based, so there's nothing actually to see when I run these tests. However, it's worth being aware of this, because typically what you're told with WebDriver is if you want to do very quick, very fast, basic HTML testing, you may as well use the HtmlUnit browser, because it's very fast. If you want to test your site with JavaScript switch off, great, just use the HtmlUnitDriver, because this uses the Rhino JavaScript engine, which no other browser uses. So it may not be JavaScript compatible. Your JavaScript may run on other browsers, but not necessarily on HtmlUnit. The HtmlUnit can be really good for testing your site without JavaScript. And that's really what we've got here. So here's the basics. I am starting an HtmlUnit driver and telling it to use headers that tell the application that I'm coming from Firefox 3.6. There are a bunch of different browsers that I can pretend to be. I'm going off to the page, getting the title and quitting. This one is creating an HtmlUnit driver, and in the properties here you can see that I can enable or disable JavaScript. So at this point I'm turning JavaScript on, because the default for HtmlUnit driver is to switch it off. The other way of controlling JavaScript with HtmlUnit is through the capabilities. So again, I create a desired capabilities and then I set JavaScript enabled capability to true. Now I think that this JavaScript enabled was only really added for HtmlUnit, because when I tried to switch JavaScript off in Firefox by setting up a capability that set JavaScript enabled to false, that made no difference. So you have to start looking in the code, the actual driver code, to see how the driver responds to the different capabilities, because there is nothing in the Firefox driver to deal with the set JavaScript enabled. Therefore you have to set the JavaScript off in Firefox by using the preferences rather than the capabilities. So we can use the HtmlUnit driver with capabilities. And again, here's the proxy code. It's almost exactly the same proxy code. For all these things with the proxy, they're all pretty much the same because we're using the capabilities to set this stuff off. Here I've set JavaScript enabled to true as a capability as well, and then running the test. So if I run this test, we won't see anything, we'll just see the test pass. So I'm just going to start browser suite up clean. If I then run this test, which sets JavaScript on, the test should run fine. But because it's not going through the proxy, nothing should appear in here, which it didn't. Now if I run it with the proxy capabilities, again the test should run fine, should be fast. But over here, we should see it come through. And one of the interesting things about HtmlUnit is because it's not very visible, you may find that you're more comfortable running the test with HtmlUnit going through a proxy, because then you can see what has happened and you know what has happened. So I'm not going to do much on HtmlUnit. I do not use it very often, but it is there, it is fast. You can set it up with capabilities. It doesn't have a lot of functionality in there for configuring, except for the capabilities. Next up is a ChromeDriver. ChromeDriver you can find on the wiki. We download the driver.exe, typically ChromeDriver.exe, put that somewhere on our drive in the path if you want to. We tell WebDriver where it is through the use of WebDriver.chrome.driver environment property. Then, if you need to, you can control Chrome through the adding of the arguments at the command line switches. ChromeDriver will produce a log when it's running, which can act as a useful debugging tool. So here's a quick example, an annotated example. We'll look at the code in the next lecture. So essentially, you can see what I'm doing here. I am finding my current directory. Now there's a whole bunch of ways of identifying files on the path. What I'm doing here is specifically, because I know where it is and I'm controlling completely the location, telling my test exactly where to find this. So I'm looking in my current test directory, the user dir, and then I'm saying I have a tools folder within there with a folder called ChromeDriver, and the ChromeDriver.exe is in there. Then I'm setting the system property WebDriver.chrome.driver and putting that path in there so that the driver can be found by WebDriver. Then it's pretty much just a case of I am using the Chrome options to add command line arguments. And I'm adding here the disable plugins argument and the disable extensions argument. And again, you can find that list of arguments on the web. And then I simply create a new driver with those options. And let's have a look at the ChromeDriver test in the real world. So the first thing I'm doing in this test before class, so this is done once per class, so all the tests in this class pick this up. I am setting the system property for WebDriver.chrome.driver, and I'm setting it to my current code directory, then up a level, then in the tools folder. So up a level, then in the tools folder, there's the ChromeDriver and the ChromeDriver.exe. So that's what this is doing. Now, later on when we look at the driver manager class, you'll see that very often what we do is we either read in from a property file or get the property that is already set up. So some of the tests when we come onto the remote WebDriver, I have set the URL for the remote driver outside as an environment variable, and I'm getting it in the test. Here, just to make things easy, I'm setting the property within the test. This is not normally how we use it, but this is what I'm doing for the purposes of this, and it's nice and easy to control it. So the WebDriver.chrome.driver property is set to the correct path and ChromeDriver.exe before these tests run, and that's why new ChromeDriver will work. So this is the basic Chrome usage that we have seen with the normal standard browsers. WebDriver variable instantiated as a new ChromeDriver, get it, then quit. Here I am creating the Chrome options. So that's where the ChromeDriver takes a Chrome option. So we can see in here, used to take capabilities, now it takes a Chrome options and a ChromeDriver service, focusing on the options at the moment. And the options are, we can add the command line arguments. We can add extensions. We can control the path for Chrome browser itself. So it's a very simple set of options, but the complexity comes within the arguments and in the extensions that we may or may not want to load. So all this does is disable plugins and extensions to make it load faster. Then we go to the page and check the title, as all these tests have been doing. Now in order to set up the proxy, I'm not using capabilities this time. I'm using the command line arguments for proxy server and using the normal string for the proxy. So this was the best site I could find for explaining the Chrome command line parameters. I'm not sure what the official one is, but this has the big list of parameters that you can pass in when it starts. I find this very useful. So let's run these tests. And if I just run all these tests, then we should expect the last one to fail because I'm not running the proxy. Great, so that was as expected. The proxy server failed. Now let's use that and have a quick look in the log. So we can see here that ChromeDriver has created a log when it tried to log it, when it tried to run the test. And you can see exactly what has been passed through, what command line switches have been used, what plugins are done, what's going on. So this is a very useful tool if you encounter any issues when using ChromeDriver and you're running your tests. So now if I rerun that test with the proxy server up, so that test now runs fine, and proxy server has captured that URL. So that was pretty much as we expected. So there's no real complexity in there at the moment, but it's a slightly different approach than setting it up with the capabilities. Now on to the IEDriver, everyone's favourite web browser and driver. Now this driver, the guys have put an awful lot of work into this to allow you to automate IE, because it's not necessarily the easiest thing to automate, and it locks itself down for security reasons. So this is a very important part of the WebDriver code, takes a lot of work and helps us do our testing on the browsers that are much more amenable to testing, like Firefox and Chrome and Opera, but allow us to run our tests on IE, which is the browser that everyone wants to see your test running on, regardless of whether that's the most important place to run your tests or not. Therefore, we have to learn how to use the IEDriver. Typically, I use the IEDriver just to run the tests. I don't use it for development of the tests, I use it just for running the tests. Now the IEDriver itself is hosted on the, well, you can find the information on the Google wiki. We have to download the server executable. Then we're going to discuss the path side for IEDriver, but basically we set the system property WebDriver.ie.driver to the location of the driver executable. Then we simply instantiate a new Internet Explorer driver, just the same as we do any other driver. Proxy handling is a little bit different in the IEDriver. Now, I'm not really going to say very much about the IEDriver here because you've really seen all this before. In here, in order to do a basic test with the IEDriver, where I create a new Internet Explorer driver, get, assert the title, quit, I have in the test set the property of WebDriver.IEDriver to the tools folder where I have stored my IEDriver, the 32-bit version with the IEDriver server. And I have the IEDriver 64 down here as well, although I'm using the IEDriver 32 in my test, and it's in my tools directory under my code, so, or above my code directory, which is why I get the normal code directory, go up a level, tools, IEDriver 32, set the property to that. Then when I run my test, it will pick up that I'm using the Internet Explorer driver, and it will run that test against IE. And you can see it's going through an Internet Explorer driver server. And there we go, the test passed. That's really all I'm going to cover with the basics of running with IEDriver. So you saw that I was setting the location of the driver through the set property WebDriver.ie.driver. Now you didn't used to do this. What you used to do, let me show you, was configure it via the path. So here I have a user variable for the IEDriver path, which I have configured to point to where my IEDriver is. Then I've added that into the path. So all I've really done is add the IEDriver into the path. I'm not setting the property, Therefore, in order for this to work, it has to look in the path to find it. So if I run that test, so our test ran, our test passed, we're all good, but we're not. And the reason we're not is that in the log here for the test running, it's saying that the path to the driver must be set by WebDriver.IE.driver. If we try and use it in the path, then that's going to be deprecated in 2.26. So the reason I'm pointing this out is that we have to learn how to read the log files. We have to learn how to read the error messages that come through in our tests. We have to be aware that the drivers change how we call them, the capabilities, the properties, the settings, whatever else. This stuff is all changing so that they can make it better and easier for us to automate. And they become ever more like each other, so that eventually I assume there'll be one standard way of calling up the drivers. We're slowly converging on that, but at the moment we're going through a period of change. And this is just one example of that. So now we're moving towards the use of the properties and not having the things on the path. Let me remove that from the path. So now it's only the property that is defining this test. And we'll see what happens. There we go. So I just point out that we have to be aware that these things are changing.
So one of the things the WebDriver project tries to do is have the browser manufacturers make the drivers. That way the driver itself will be kept up to date when the browser is kept up to date. So every new release of the browser would have a new release of the driver that would be compatible with it, because it would be owned by the person that makes the browser. It will be compatible and they'll be responsible for keeping it up to date, and it just has to correspond to the standards. That is now happening. Microsoft have created an Edge WebDriver. They didn't create one for IE, but they've created one for Edge, and you can get it here on their site. If you do web searches for the Microsoft Edge WebDriver, you might end up in the wrong place. When I did that, I found a whole bunch of old drivers that I could not get to work. This is the official page for the WebDriver. Go to this page when you want to start using the WebDriver. Now at the moment, this is what the page looks like, and it has a couple of downloads. The thing about Edge, what I've found is you should use the version of the driver that is appropriate for the browser. That makes sense, but let's have a quick look. I'm going to get Edge up. Edge is on the side here so that I can compare it with what is listed in downloads. So if I go into Edge settings and scroll down to get to the bottom, and it's telling me this is Edge 25.10586. There's release 10586, which says it supports 13.10586, which is Edge HTML 13.10586. So I would download this version of Edge to use with the current version of Edge that I have installed. Now most of the time I think it comes packaged as an MSI. This is an MSI. I think the Insider's build comes as a .exe. All the MSI does is install the .exe to a place you want. It doesn't add it to your path, it just unarchives it. So the way you're going to use Edge in the code, and you'll see this in a minute, is you're either going to add the folder where you install the Edge driver to your path. So on this machine, if I was to add it to my path, I would be adding c:/webdrivers/edge driver to my path. I'd add the folder to my path so that when I do new Edge driver, it knows where to look for the Microsoft WebDriver. The alternative is that I can set the property WebDriver.edge.driver to the actual executable, which in this case would be c:/webdrivers/edgedriver/Microsoft WebDriver.exe. But the point is, you download it from the official site, and you can see at the time of recording this video that Edge is still a work in progress, and you can see what is currently supported and what is not. So if we look down here, so alerts are not supported in this particular version, so we would expect those tests to fail. At some point, hopefully, the full spec will become fully supported and everything will work in Edge. So I've added a simple test for Edge in the code base. You can see it in the drivers package. Now all this does is it starts up an Edge driver and visits a page and asserts on the title, then closes the browser. Edge driver is new in WebDriver, and it's simply a wrapper that starts up the Edge service so that you don't have to, and creates the driver. Now you can pass in Edge options and you can pass in capabilities, because essentially it's a remote WebDriver. At the moment, I don't think many of the capabilities are supported, but in the future it will be. Certainly when I tried to use proxies at the time of writing, which is July 2016, the proxy wasn't working, but Edge is a work in progress. It will change over time. Quite a lot of the tests are actually running on Edge, which surprised me. So what I have done here in this test, and this is the same way that we work a lot, instead of adding the Microsoft WebDriver into the path, if I did that, this test would work fine. What I've done in the before class is I've set the WebDriver.edge.driver property to the location, which is relative to my code base. And you have a choice as to how you want to do it when you experiment with this. If you add Microsoft WebDriver to the path, then you should basically just not have these lines and just have WebDriver driver equals new Edge driver. If you want to control the path, then you can do that. I've added this into the driver class as well, so you can set the Selenium2 basics.WebDriver property to Edge, and you can use it in driver, assuming that you've either set up the path as coded in driver, or you've added Microsoft WebDriver to the path. So if I run this, that was quite fast. Edge is quite fast. When Edge works, the tests are running quite quickly. Now if you have a look in driver, the changes I made are very simple. It's essentially this code in the driver class. Let me go to that. Control N, driver, there we go. And there's Edge. This is all I've coded in for Edge. I've basically defaulted Edge driver to be in c:/webdrivers Edge driver, but you can add it into the path wherever you want, and I simply pass in the property as Edge. So I actually have an Edge suite in here. By the time you come to look at this, it may or may not be here because Edge may be fully compatible. If I start to run this, it's starting, and then stop it, if I now go up to the edit configurations, I can force this to run on Edge in the IDE. So I'm just setting the property that's going to be passed through to force it to use Edge in the driver class. If I run this again now, it should start up Edge. There we go. Edge is running in the back. And it's very quick. So I'm just going to leave that running. You can experiment with Edge in your own time.
So if you come this far, you've had it easy, right? Because we haven't really done different browser testing. Now I'm going to ask you to. And tests will fail. And tests will fail because you're running the browser under, or you're running tests in a different browser, which will have different timing issues. Some browsers run slower than others. Some of your selectors will run faster on some browsers than others. Some of your selectors will work on some browsers, but not others. You will experience driver issues, because there will be bugs in the drivers related to certain types of functionality. For the longest time, Opera had issues with alerts. I'm not sure if they're fixed or not. Maximizing windows wasn't supported. You'll see that different drivers throw different types of exceptions. Different exceptions get thrown. Sometimes you will find that your browsers are incompatible with the driver, that the browser is upgrading in the background, that the different dialog messages come up, that the extensions that you want aren't in there and you have to add them, and then you have to overcome the differences with the extensions over time. I mean, the whole bunch of things. And you're just going to have to put up with that and experiment with it, because that is the price that you pay for running your tests in different environments. And Grid can help with that. Grid isolates you a little bit from that, and we'll look at Grid later on. But it's very important that you start running your tests on different browsers. It's also important that you try and put your tests through continuous integration, because there's a difference between running your tests in isolation, as we're doing in the IDE, and en masse in a continuous integration server. Different synchronization problems show up. Different assumptions that you've made in your tests show up. It's very important to, in the real world, try using different browsers as early as possible, rather than leaving it late, because then you will discover issues in your test abstractions and your test framework. It's not just when you're automating about demonstrating that your system works cross-browser. You have to accommodate this. The drivers do their best to allow this to happen, but you will have to do some work in your tests as well. Now you can probably guess what I'm going to try and get you to do for the exercises. And that's basically look at some of the tests that you've already done and have them run through different browsers. This is an experiment for you. Which ones work well, which ones don't, which ones still have synchronization issues that you haven't resolved. Now you've covered most of the information you need in order to do this by yourself, which is why I haven't put together some answers for this. Essentially, I've written tests that I can run across the different browsers. What I also want you to do, so spend some time doing this. It's important that you experiment with it and you try and get this stuff working. And as you do that, the more browsers that you run it through, what I want you to do is start looking at your code and thinking, how can I make this easier? At the moment, what you'll probably end up doing is changing the new Firefox driver to new ChromeDriver or new Opera driver. How can you make it more easy for you to switch between drivers? Can you use environment properties? Do you need a properties file? Would that properties file be a .ini file? Is it an XML file? Are you going to create a CSV file? Are you going to have a class that allows you to pull in this information as a driver manager or a supplier of these drivers? What are you going to do? Start thinking about that, because that will help you when we start to come on to Selenium Grid and when we look at the later custom driver manager and supplier classes.
Okay, I just want to give you a quick overview of GhostDriver. A few people have asked for GhostDriver on the course. Now, when WebDriver first came out, it had a driver for HTTPUnit. And that's a headless browser, which means when you run it, you don't actually see a browser in there. But theoretically, it's making HTTP calls on your behalf, and you can do all the normal web testing. Now, I never found HTTPUnit particularly useful. The JavaScript never really worked for me. It was always using Rhino. Nothing was ever compatible. But recently, PhantomJS has come out. That's a headless browser. This has as a standalone application, this has a lot of functionality where you can write various applications in JavaScript and do a whole bunch of things on them, which I haven't looked into. I haven't used this properly. But in order to use this with WebDriver, someone created the GhostDriver project. Now this is a driver for the headless browser Phantom.js. Now in practice, I have found this to be an incredibly reliable browser. It's essentially a WebKit browser that's headless. Now that doesn't mean you can't see what's going on, because you can take screenshots from it. So here is a couple of screenshots I've taken using Phantom.js as a driver. This is me accessing Google, and one of the things that Phantom.js lets you do is change the user agent very easily. So this is me using WebDriver to access Google with Phantom.js, telling it that I'm actually on an iPhone with a very low resolution. And this is me telling Google I'm on an iPad, sending through the right user agent headers for an iPad and changing the browser display to the right size. So I'm going to give you a quick overview of how to bring this into your project. Now what we have to do is we have to bring in the dependency into our project. Now if you have a look on the GhostDriver website, you'll see the right dependency to bring in. I'm using 1.0.3, I think that's the most recent one. You also need to download the Phantom.js application, because you're going to be accessing the Phantom.js.executable. Let me show you a quick test using it. This code is not in the main code base for the course, but it is available on GitHub. So there should be a link on screen telling you how you can get hold of this. So this is how we start it. Same as normal. Let me just skip out the top here. Because I've put the Phantom.js.exe in my source folder, I'm basically using the user.dir property to get access to the top level directory here. Then I'm saying Phantom.js is in the tools directory in Phantom.js Windows, Phantom.js.exe. I'm sure there's a very similar way of doing this on Mac and whatever other application you're using. Remember, on Mac you tend to have to jump into the actual executable itself, because all the files you download onto Macs tend to be zip archives that the file that you're executing is part of. But I'm sure that's explained on the Phantom.js website. It's a lot easier on Windows because every folder is actually just a folder, and then we access the directory. So just as we would, if we were trying to access a different version of Firefox, we would tell it what the binary is. Same in Phantom.js. So here I'm creating the driver that we're going to use. So I set up as a normal desired capabilities, set JavaScript to true, then set the binary path for the executable. Then I can just start up the driver with those capabilities, and it's nice and simple, same way we do with every other browser. And at this point we're just working with a driver, so I can do all the normal driver commands, driver.findElements. I can do the normal driver.manage.change the window size, all the kind of normal stuff that we would do in WebDriver, but it's all running headless. So if you do want to take screenshots, use the normal WebDriver screenshot functionality to take the screenshot, output it, download it. And now the example here, which when you look at the source code you can have a look, is just me testing some redirection on websites. And those screen captures that you saw earlier, they're just me experimenting with a link checker, but I'm using Phantom.js to do it. So I'm not going to go into a lot of detail on Phantom.js, except to show you it's very easy to add into your project. It's just a dependency, and it's just a .exe we need somewhere. Then we start it up like any other driver. We just tell it where the path is, create a new driver instance, then we have access to the JavaScript executor, the can take screenshots functionality, all the normal driver stuff. Because it's headless, it runs quite fast, it's got good JavaScript support, and it's essentially a headless WebKit browser. So it's got a fair amount of standardization in there. So if you do want to experiment with GhostDriver, it's very simple. Have a look at the code that is linked to on screen now. I'm sure you'll manage to do it at this point in the course if you want to.
So let's have a quick look at Remote WebDriver. Remote WebDriver is the other driver. And what Remote WebDriver does is it connects to a server somewhere, issues requests to that server, so that server can then drive a local browser that's on that server. Now for our purposes, we don't really need to do very much. We've already seen how we configure a driver through the capabilities. That's what we use with a remote driver. So the only real difference here is, here I'm saying I want the desired capabilities for Firefox, then the version, then the platform. Then you can see I issue a new remote WebDriver command. And the URL that I put in there is the server URL that we have to connect to. Now I'm going to be demonstrating this using Saucelabs because we haven't covered Grid yet. I figure it's easier to have you get started with remote WebDriver on Saucelabs and see its capabilities, then move you on to running a grid locally and connecting to that. So all the examples here are using Saucelabs. Now Saucelabs uses a unique URL for your account to connect to, which I have here in a system property called Saucelabs URL. That way I can release the source code for this lecture without giving away the connection details from my Saucelabs account. And once this code has executed in the ADriver variable, we now have a driver that we can issue the normal get, interrogation and manipulation commands on. Some commands will not be supported, so get used to that. Again, this is just another driver that you're using. Some things are not supported, some are. Most things that you will need to do will be supported. And remember, with the capabilities, we can set profiles. We can configure profiles and options. So here you see an example of using the Firefox profile and putting that in as one of the capabilities. And also using the Chrome options as part of the capabilities. We have a lot of configuration that we can still do, even though we're executing our test remotely. So that was a quick whistle-stop tour in slides. But now I'm gonna drop down into the actual code, and I'll give you a demo of Saucelabs as well. So let's have a quick look at Saucelabs. Saucelabs is, I don't know, potentially the coolest testing service. So two things that really impressed me in testing on the cloud: Saucelabs and BrowserMob. BrowserMob got taken over by someone else and changed their name. BrowserMob was a performance testing tool based around the Selenium, and Saucelabs is a grid in the cloud that we can run, and more than that. So with Saucelabs, the blurb is clearly coming across the screen here. I can run my tests on their cloud using multiple versions of browsers across different versions of operating systems. We get a video of every test that we run. I can do manual testing using their grid setup, so I can connect to their machines on different versions of Firefox and do manual testing over the cloud. Let me log in and see this. So there's a free account. I'm not trying to sell you a service. What I'm trying to do is introduce you to remote drivers without the necessary hassle of setting up a grid. Now, when we do get onto grid in half an hour from now, there's not that much more to do, but I want to show you the capabilities of what a really good grid setup can do. Now, the free plan gives you 100 minutes across these different browsers and 30 manual minutes per month. So whilst you're still learning and experimenting, this is probably good enough. So let me just log into my account. So you can see here, this is my free account, and I have a bunch of jobs here, some with errors, some with not. So if I quickly show you what you get once I create a job in Saucelabs, you can see that there's a video here of the test that ran. Now I haven't explored all the Saucelabs features because basically I use it for connecting, running some tests and checking it. But you can see here there's all the commands that were issued from my test coming through. You can see that I'm actually running tests that you've already seen. So I'm going to this URL, I'm finding elements, clicking on them, checking that certain values are set. These are all tests that you've seen. Here are some screenshots as we went through, but probably what's most impressive here is the video. So I can review the test that was executed on the Saucelabs grid. And this is the test that I'm about to show you in the actual code. So you can see we've gone up the form, we've done some checking, then we've done some of the frame tests. Now executing the tests over Saucelabs is a little bit slower than running it manually because you're issuing requests off to the cloud. But the fact that we have a video, if you're doing cross-browser testing, sometimes all you really care about the cross-browser, because the functionality works, is what does it actually look like. And that can be a hard thing to achieve. Here we've got a video of the test, which you can download if you want to. I just find this stuff amazing. So I can also, let's see if we can figure out how to do this, do manual testing on this. So I'm going to start a manual session if this works. So I'm going to just go off to http://compendiumdev.co.uk, and this looks like we're using Linux with an Android 4 browser. Let's not do that. Let's use Linux with, what should we do for free? Let's really go back in time and see what's going on with Firefox 3. So you can see that they have loaded Firebug into the browser, which is particularly helpful. We already know how to do that with the profiles. So here is I'm going back in time here. Chances are you won't, if you're doing automation, do a lot of the manual testing stuff. But if you're working cross-browser and your tests are failing cross-browser, you have the ability to come into a manual session and do the normal. Okay, clearly not here. Where's my Firebug that is supposed to be in here? It really doesn't look like Firebug has been installed with this browser. Maybe this is too early for Firebug. I don't know. But if you're doing manual testing, if you're doing automated testing and you're doing it across the browser, you have the ability to connect into Saucelabs and use the different browsers that are on here. So let me just end this session. So it looks like a video. So there's my manual session, and there's that video associated with it. So I can do manual testing across this and take videos of it. This is just really, really useful set of resources. Now if I go into resources, let's have a quick look at their documentation, because they have all the code examples and everything else that you're going to need. So pretty much all the code that I'm using pretty much came off their website. So if you want, you can bring down their Saucelabs libraries to help you. I'm not using any in our test. We're not using any Saucelabs specific code in here. Although Saucelab do have, if you decide to use it and look into it in more detail, you'll find that they do have capabilities and things that you might want to have a look at. So you can see here I'm giving away my free code, so I'm going to have to change my sign up now. But this is the secret code that you get for connecting into Saucelabs. And this is an example of test. So this is pretty much all I have copied across into the source code that I'm using. Okay, so I would leave you to explore Saucelabs. In fact, I would leave you to sign up so that you can use it in your own tests and explore at your leisure. Everywhere I have gone that is using WebDriver, when it's got to the point of needing to use multiple browsers and cross-platform, I have always checked to see whether Saucelabs is a better bet for us than trying to set up our own grid. At some point, I'm looking forward to using Saucelabs as a paid account so that I can get maximum value from it. At the moment, the free account does me just fine for experimentation. So So let's have a look at Remote WebDriver in code using Saucelabs. All the tests in here you have seen before. The tests are not what is important. I've basically just copy and pasted these. What is important is that at the start in the @before class, I am setting the driver up as a remote WebDriver using my Saucelabs URL from, and I've put it in an environment variable. You will take it directly off the Saucelabs code. And I am saying I want to use Firefox version 5 on XP. In fact, what I'm going to do now, because you saw some of that in the video, I'm going to say I don't care what version of Firefox it is, but I want it on Linux. Let's try running these tests cross-platform on Linux. So if I just run these tests, all the tests passed. We didn't see a browser. That's fine, but all the tests passed. So let's have a look in Saucelabs and see what happened. So if I look at tests on my account, here is the test that I ran. I can tell from the time. You maybe can't. That's fine. Unnamed job, because Saucelabs does have a way of naming these jobs. I just haven't used it because I'm using the most basic capabilities. I'll leave that as an exercise for you if you want to name these jobs when you start running them. And here is the test video. So I'm going off to the basic form, filling something in, then it's the frames. Great, so let's just have a quick look at what happens within Saucelabs when we run this. Because really, I just want you to take away from this, we can set up a remote driver that is connecting to a server, and it is really no difference. I haven't changed any of these tests at all. The driver is instantiated outside the test, I get the page, I do some things. So, in fact, I have not tried this. I'm doing this now on video. I may have to completely edit this out, but I'm going to try and run this on the Mac and see what happens. So I'm just going to run this test, nip back to Saucelabs, and hopefully we'll see a new job appear. There it is. So I can click into this. It's saying loading live video. So I can see the test actually running, which is quite exciting because it's running on a Mac in Firefox. I don't own a Mac, so for me this is a journey into the land of the trendy people. And so I can see that in terms of Firefox usage, I haven't really missed much by not owning a Mac. It's much the same. Now there are some interesting things in there. Saucelabs have the concept of a breakpoint job, but also I can take control of the test in the middle if I really want to. But all of those things are Saucelabs features. What we want to point out for the remote WebDriver feature is we instantiate the remote WebDriver with the URL of the server. Everything else is controlled through the capabilities, then our tests should be as normal. If we are trying to do something that is not supported, we'll probably get an unsupported operation exception, and then we might have to change our tests or not run those across remote. However, normal simple tests, basic tests, the vast majority of your tests, you will be able to run on a remote WebDriver without changing it. And remote WebDriver gives you the ability to choose different browsers on different platforms. And when we come into Grid, you'll see how grid schedules our tests across those different platforms. And let's learn the basics of Grid 2. We can find the Grid 2 wiki page on the normalcode.google.com/p/selenium/wiki/grid2. And there's a lot of information on here as to how to use it. So all I'm really doing is I'm going to explain the basics of Grid 2 and how to use it in a couple of circumstances. Have a look through the wiki page. That will explain a lot of things. Then just experiment with it. So what we do, or what we need, is we need to download the Selenium server standalone jar. We need to have that in a directory somewhere. So I have it all in a tools directory. So remember, I have a tools directory that has the ChromeDriver and the Internet Explorer driver. Well, I've got a Selenium grid folder in there as well, which has the Selenium server standalone to 2.50 jar. Now, when we were using Maven, we didn't really need to download any of the things because it was there in Maven. When we want to start using Grid, we need the actual jar file. And everything we need is bundled in here. So it's got the Firefox driver, it's got Selenium, it's got the hub, it's got the nodes, single file that we're going to use. Now you can configure this stuff from the command line, but you can also configure it from JSON files. And I tend to use JSON files because then it's a lot easier to read. I don't have to mess around with a command line as much. All the instructions for using it with the command line are on the Grid 2 wiki page. I am going to focus on using it from a JSON file because I find them easier to edit and work with. So basically what we have is a hub, and that is the server that we are going to be connecting to from our tests. Then we have nodes, and they can be on separate machines, and they're basically what browsers and drivers are available for us to test against. And every time you start up a node, it registers with the hub. So you have a single hub, we connect to the hub to run our tests. The hub has nodes that are registered to it, which tell it which browsers are available. Then the hub sends your requests off to one of the nodes to execute the test based on the capabilities that you decided that you wanted. So let's have a quick look here at what we've done. So I've done everything in batch files because it's a little bit easier and it means that you can download it. So let's look at the start hub. So the hub, remember, is the thing that we want to run. From the command line, I could just start a hub with the defaults. So I can issue a java-jar, Selenium server standalone, etc. in the role, like -role, hub. So I'm starting up the Selenium server as a hub. Let's see what happens. And this basically just launches everything as the defaults. So you can see that we have something now sitting on port 4444 because that's the default for a hub. So if I go into here now and do localhost grid console, we can see the grid hub. So there's a grid hub running and it is version 2.25. And we can see what it is configured by. Now this config online through the host is very useful because these are all the values that we can set in the JSON file. So here's a hub.json. All of these bits of information are in here, so we can see what is available for us to configure. But what we have at the moment is we have a basic hub running. With nothing connected to it. So I've written a batch file for the node, but you can see that I can start a node from the command line with the defaults, and I basically run java-jar, Selenium server standalone 2.25 jar -role node. And I have to tell it which hub it is to connect to. So our hub is running on localhost on port 4444. We saw that when I went into the browser to look at the config. And I basically hit grid/register to register this node from the command line. So let me get into the node. So I'm just doing this basically from the command line. And you can see here that the node by default has started on port 5555. And it is currently polling saying, is there anything to do? No, not really. Is there anything to do? No, not really. So now if I go back and look at the hub, remember this grid console is for the hub, I can see that there is a node. It is available for me to test, and I can test against Firefox, Chrome, IE, because it's basically set up with the defaults. In fact, this is the Selenium 1 Firefox, this is the WebDriver Firefox, so it can respond as a Selenium 1 hub or as a WebDriver grid. Now if I look in the test, change this to Firefox, this is pretty much what you saw when we're working with Saucelabs. I'm creating a desired capabilities with Firefox on platform Windows, and this time the remote WebDriver URL for the server is localhost 4444, which we know that's what this grid hub is running on. So my request is going to connect to the grid that is running on our machine. We'll see that there is a Firefox node registered, and we'll send our requests through our hub to our node that is running on localhost. I've got a single test here which does the simple interaction stuff, and let me run this test. Okay, so a couple of interesting things. You saw that the Firefox browser opened in the back there because it's being started up by a different process. Let's also look and see. So our node is telling us that it had to do a whole bunch of things. They're all listed in the command output here. This is the kind of thing you're used to seeing when you're running through the Selenium RC server. Our hub is pretty clean because that's not reporting anything out. It's the node that is reporting all the information. And our grid is pretty much saying, I'm okay. Now what I'm going to do this time, I'm going to run it again. But this time I'm going to have a look at the grid window. So you see what happens when this starts to run. So let me put this into debug mode. Put that on that assert false. Let's debug this. What I'm going to show you is that the grid itself, that status is up to date. So when a test is running, we can look in the grid and see which of our nodes are occupied and which browsers within that node are occupied. So our test is now in debug mode. So we can see over here, if I refresh, that this node, the first Firefox node in the WebDriver part of the Firefox, is currently being used. It's in action at the moment. So the grid itself is running as a server. You can check to see what is up to date and what is not. Let me stop this test. So we currently have a default grid, a default node, and it's telling me that I can use Chrome here. So let's say I want to use Chrome. That's what the grid is reporting it can do, so let's do that. Now, the test has failed because we haven't told the node anything about the ChromeDriver. We haven't set that ChromeDriver property up. It's not being set in our test because really it's the node that needs to know where the ChromeDriver is. So we do that either by setting the properties on the machine that the node is running on, or we can pass it in through the command line. So I'm going to do that and add that to the command line. So I'm going to say -d webdriver.chrome.driver, and because it's in the same path hierarchy, I'm just going to say look in the folder above, then in the ChromeDriver folder, then find ChromeDriver.exe. So let me stop the node. So I'm going to say same command as before. I want you to register with localhost, and I want you to be aware that the ChromeDriver is in this particular folder. So now, when I run the test, I haven't changed anything in the test, I haven't set any properties in the test. There we go, the ChromeDriver has come up, the test has passed. So it was the node that I had to configure and tell it where the ChromeDriver was. It's the same with any of the drivers that you use, it's the node that you have to tell where those things are. Now we can configure the location of the browsers in the property files, the node files, but the location of the driver itself is in a property, which means we associate it with the JVM or set it up as a system property. So let's have a quick look. So that was it from the command line. It's pretty simple. I tend not to use it from the command line, to be honest. I tend to use it in the hub configuration. So let's have a look at what the hub configuration is. Now the documentation is pretty good. In the documentation itself, down here it says you can configure this stuff by JSON, and it has default files for both the node and the hub. This is pretty much what I've used when I'm setting up mine, so this is where I've started from. I've had to change it a little bit. I'll explain the changes. And the way that we use this is when we start up the hub, I say -hub config in the hub.json file. And for the node, I say -node config node.json. So this will be the command that I execute to start up a node that's configured by JSON, which knows where the ChromeDriver is. So let's close everything down, then start up the hub and the node again. But this time configured through JSON, and we'll see the difference. So the hub, this is default. I haven't changed anything here at all. This is the straight hub configuration from the wiki page. But you can see here that I can change the port that the hub is running on. 444 is the default that we're used to. I'm leaving it there. And you saw the other properties that were available in the config file, but I don't need to change anything there. The node is the one that I have changed. So the node JSON, you can see that everything we're doing is around WebDriver. So I haven't put in the Selenium RC browser config like this one. That would be Selenium RC. We're using WebDriver. And I have said that our host, the hub host, where our hub is running, is on localhost. I've added this in. And I basically said we are running on localhost as well. And I think that's all that I changed. So now, if I issue this command, we start the hub up first. In fact, let's start the node up first so we see what happens. So there is no hub running. Got the node, and the node is going, yep, I can't register. I can't register. What do you want me to do? So it's still trying to register. So let's start up the hub. Again, hub config for the JSON file. So that's the hub started. Then the node is registering, and the node has registered. So now, let's have a look at the config that we have. So here's the grid console for the old one. Let's refresh this, and we can see that this is the config that we set up for the node. It's just the Firefox, Chrome, and IE that was in the node config.json. Firefox 5 instances, Chrome 5, IE 1. That's exactly what we set up. So if I run the test now, you should get the same result as before. The only difference is that this time we configured everything through JSON files rather than from the command line. And the only thing that we added into the command line was the role. So this is the node configuration. We start up with the role for node, that's important, what the config file for the JSON is, and where to find the ChromeDriver. And the hub, we started in role hub with a config file. Now we could download the Selenium server standalone, stick it on another machine, start up another node from there and register into this one. I'm not going to do that here just now because it's pretty much exactly the same, but as an exercise for you, you might want to try that. Create a virtual machine, stick a node on there and connect to a hub on your local host and then run a test against it. Selenium Grid is really useful for, well, you saw it with the Saucelabs for running against lots of different platforms and lots of different browser combinations. It's also useful for running tests in parallel, because you saw there that the hub had 11 browsers available to us. So if we have the ability to parallelize our tests, we can send them across different instances of Firefox and different instances of Chrome. So one of the things we're going to look at now is the notion of a driver manager or a supplier class. You've seen that throughout the source code examples that I've done. I generally call driver with a capital D .get. Now I've done that because I have a driver class in the background which is helping coordinate the WebDriver for me so that I don't have to instantiate a new Firefox driver all the time. Now every single production project that I have been on, we have written some sort of manager class, some sort of provider class that allows us to abstract away the instantiation and initialization of the driver. Now we do that because sometimes we want to have a default and not worry in our tests about which driver we're using. Sometimes we want to control the driver that's being used through the continuous integration. So we want to set it in a property and have the different Hudson builds push that property into our build process, and it's kind of like injecting the type of driver we want to use. Rather than having to code that in each and individual test, we do that in a general driver class. And there's a whole bunch of different approaches for doing this. We're going to look at a couple in this section. I'm going to look at the one that I created for this particular course to help me get to this point in the course. We're going to have a look at the one that's in the WebDriver test code. We're going to partly do that so that you see that the test code is there and can start looking through that for other hints and tips for how to use WebDriver. But also that's a very different style than I typically use and a different style than I use in production as well. I'm going to quickly show you the one that I used for the Selenium Simplified book, because that again has a different style and that uses some of the notions that we need to put it into continuous integration. And we haven't covered continuous integration in this course yet. And then at the end of all this, I'm going to ask you to do an exercise where you construct a very simple driver manager for yourself, which will create a instantiation of WebDriver based on a property. So I'm going to show you the manager class that I've got in the code base that you're using here. Now you can see how I use it. I've got driver.get. All of this is controlled by my WebDriver manager class. So if I jump down into driver, then we've gone into the code. So you can see where it is. It's over here. And I've put this in the main trunk. This isn't part of my test code because this is part of my abstraction layers for helping me work. If I put any page object models or anything like that, they'll go in my main branch rather than the test branch, because I keep the tests in the test branch and I keep the support code, the code that I'm using to test my application, in the main branch, in the main package. So that's what this is doing here.
So let's have a quick look through this. Now this uses a static for a driver. So this field is for the class itself. And the way that we're accessing all of these methods is through static methods. Therefore, I don't ever have to instantiate driver. I access everything statically. This may or may not be the right style for what you're doing, but this seemed like the right style for what I was doing here. So I can just say driver.get. Now you can see in here, I have declared a couple of different browsers that I can enumerate to define which browser I'm going to use. There are different ways of doing that. You could use the browsers that are built in to Selenium. You could create your own classes. You could create classes for these rather than enum. I'm doing this very, very simply. In fact, the way that I build these classes up is very, very simply. I build up exactly what we need and when. So at the moment, I don't have anything that uses properties in order to set this, because we haven't put this into continuous integration yet. I haven't needed it. So as soon as I do put it into continuous integration, that's when I will add the setting of the browser that we're going to use from a property. So let's scan down here. So the only set method I've got is to set the browser. So in my test, I can say set and then choose the different browser that we've got. Now here's the basic get method. So when I do driver.get, it will, if we haven't got a driver, then create one based on the property that we've got in that we've already set. So if I've said, and by default, that's Firefox. So if I just call get, and we haven't created one already, it will instantiate a Firefox driver, set it to the static variable, and set the current driver, break out the switch statement, and then it should return the driver that we've set. So this is where all the complexity is in this get method. If we have already instantiated one, then I check to see whether I can get the handle for that window. I'm assuming that if I can get the handle, then the browser is still alive. If it's not, then we may have closed it, it may have crashed, something may have happened. Therefore, what we do is we quit and set the driver to null, then get another one. And because that could set me up in an infinite loop of constantly calling the get method, I've got a recursive stop in here so that if we come in and again find that the driver is not active, then I will stop and throw a runtime exception. There's just a stop and infinite loop. I'm not saying that these coding styles that you're seeing here are the best ones ever. What I'm pointing out is that this practice is very important and is used everywhere. So you can also see that I can get for a particular URL and state whether the browser needs to be maximized or not. So I call the get function to get the default browser instantiation, get the driver. Then I will use the get call on the driver to go to a particular URL. And if we are maximizing it, then I will maximize the window. Now I created this when we were writing some of the earlier tests for window management. I didn't have this method in here until I was doing window management, and then I found that I needed to expand my driver manager class to support the functionality that I needed. And this is the get that you'll see in most of the tests, where I just call this particular get method where it uses the default driver for a particular URL and maximizes it. And that's why most of the tests, when you see them run, maximize the window. And you can see here I have a quit, which basically says if we have a driver instantiated, then call the quit on that driver and set the driver to null. And that's all this particular driver manager does. It basically says keep reusing the driver manager until from the quit method we start it up. And that's really all this driver manager does. It basically says get me the default browser as defined in the field for browser name, the current driver, get that. If it's still running, return it. If not, create a new one and quit. And the only other thing that's important to note is that when we first instantiate the driver, if driver is null, Then we do all the things to create the driver. The only other thing that I do is I add a shutdown hook to call the quit method when the JVM shuts down. This means that no matter when my tests run or how often the tests run, when the JVM that's running those tests stops, it will quit the driver. So I can quit the driver as I go through, get new ones. If I forget to quit the driver at any point because I don't know which test is going to run in which order, the shutdown hook will run when the JVM stops. This is just a quick Java hack for saying I want to run some functionality when we have finished doing all our work. I think that's really all there is to say about the driver class at the moment. You can look through it. If there's any questions, then put them in the forum. It is fairly simple once you get your head around it, and it doesn't really do very much. Okay, now we're going to have a look at the source code that comes with Selenium as part of the test code in Selenium. Now you haven't downloaded that, that's not part of the source packages. So you either have to pull out the whole Selenium source code from the version control system they use, or pull out just the client test stuff, or view it online, which is what we're going to do here. So here's the horrible URL. You can find it in the slide notes, or pause this and see it. Or even just go on to code.google.com and search for the WebDriverBuilder probably. But there is the full path name. Hopefully there's enough on screen here at the moment for you to find this source code. And I will put a link to it in the description. So what we have here, this is much more production ready, or kind of solid production code than I tend to write. Even in the production test code we write, I try and keep things as simple as possible, make it very easy for everyone else to maintain. Now the code here is not complicated, it's just been written from a very different point of view and very different style of writing the test code. But it does much the same thing. So the WebDriver Builder itself, you can see none of these are static classes, so this will be instantiated, so you have to do new WebDriver Builder .get based on the capabilities that we've set up. And you can see here that there are a bunch of suppliers that have been created, and when we ask for one of the browsers, it runs through the suppliers to work out which one is most appropriate to get. There's a bunch of support classes behind this. So we've got all the suppliers that are in here. We can have a look through those. We've got the browser to capabilities mapping class, so we can see which capabilities are going to come back at which point. And you may want to go down the road of emulating this style of code. This is a very developer-centric type of approach for building it. Very, very good object-oriented approach for doing it. You can see that the approach I tend to keep is much, much simpler. Basically, here's a property, get me some stuff back. But that's only because I haven't necessarily needed to introduce the complexities that this class is trying to handle. But it's worth looking through the code online in here and getting your head around it a bit more and seeing how it works, and see if there are things in here that you want to pull out into your code base when you construct your own driver classes. So the main one to look at, again, is the WebDriverBuilder class, and that will be your starting point for then going through and looking at the supplier interface, the different suppliers, the browser capabilities, all these different parts of it, and just have a look through and get your head around it. And this one is different again. This is the source code for the Selenium Simplified book, where I created a Selenium manager for that. Now this one is different because This one runs under continuous integration, so it has to handle the properties to define things as part of the build process. And I've split it into two parts. So I have a static class that is wrapping everything, and I have a class that can be instantiated. So if I do want to manage multiple browsers, I can do that through the creating of multiple Selenium managers. But for most of my tests, I access them statically through the Selenium manager. So I just say the Selenium manager.get Selenium manager, which will return the current instance of a Selenium manager class that I can use. So if I have a quick look through this, you can see that I have coded this to allow me to use the Selenium 1, the Selenium RC API, or Selenium 2, the WebDriver API. So all of this is wrapped up in here. And this code, you can find it, by the way, on the main page for the Selenium Simplified book, which is compendiumdev.co.uk/Selenium. Look right down the bottom, and there's the source code. And it should also have links to the different repositories that you can find this in. So you can see here that I have the ability to read a properties file to define which browser that I'm using. You can also see that I look in the system properties to see which properties. And the way that this works is I call the reset properties, which reads the properties from the properties file, but then overwrites them if there is anything contained in the system properties. That allows me to have a properties file as part of my local development process, but overwrite them through the environment variables as part of the continuous integration without having to worry about overwriting properties files or amending property files. I just set the environment variables. So you can see that I'm using the system properties. If it contains this key for the Selenium browser, then I set the value for it, and it will overwrite the one that I've set in here as part of the property file. So if you have a look through this, you can see how to access properties files, access system properties, and that's really all we're doing. Then the start method in here will be much the same as you've seen, particularly for this create a Selenium 2. So all the code that we've been looking at has been for WebDriver. So create a Selenium 2 session is about creating a WebDriver, and you can see here all it really does is, are we using the same URL, in which case keep the browser the same, otherwise create a new driver. Now you can see that I haven't got the complexity in here for having shutdown hooks or closing the browsers. I rely on the tests doing that. And also, when working with the Selenium RC server, I have to do things like close the server if we can't access it, send the HTTP commands through, otherwise assume that it's running and just start using it. So again, I'm not going down into these in detail simply because I want to show you the different principles. So the main principles are, we have a properties file which I can then override with system properties. So here's that properties file locally in my build process where I can say browser, and this is set to Firefox. But if I have a system property called selenium.browser, then I can overwrite that setting in the properties file. And if there is nothing in the properties file, so this handles loading property file, couldn't find one, but the properties are still set up. If when it tries to get the property from the local properties object and nothing has been read from the file, then it defaults to Firefox. So I have defaults all the way through here. If there is no properties file, it is set using this getProperty method here as the default. If it's read in through the properties file, then that's great. It will be used unless it's overridden by the setting of some system properties. So I hope that makes sense, because we're going to ask you to try and do this. Okay, so your exercise is to do pretty much this. Try and create a driver manager. Create a very simple one, call it whatever you want, and have a single method on it called get, which returns an instantiation of a WebDriver based on a system property, and we'll use the system property Selenium2basics.driver. So in your test, you'll have to set that property and return a instantiation of a WebDriver that is appropriate for the property that you set. Give it a shot, see how far you want to take it. I am going to create a very simple example for this, and I'll show you how we grow it through a test. So I will write one as I write tests to handle what we need. But give it your best shot, see what you do. If you want to try and pull in things from property files, feel free. It's up to you to let your imagination run on this one. But I guarantee that when you start doing this in production, you will have enough opportunities to test your metal when you start creating these own driver managers, because they will be unique to your circumstances. Okay, so I hope you did okay on that. Now I'm going to create one completely from scratch here. So if I do new package to put this stuff in, I'm going to call it driver manager. And I'm going to need a new Java class for driver manager test. And we'll drive everything from here. So first of all, so let's create a Firefox one. So I'm going to need to set up a system property, and we are calling it Selenium2basics.driver. I will set that to Firefox, and then in my test I will do a driver equals, I'll call this driver manager to distinguish it from the other one that I've got in the code base, and I'll say get, so get me a driver, and we will need that. I'm going to stick that in a local variable for the moment. Oh, I don't want a connection. I do want a WebDriver, so let me get rid of that. That's better. Great, so now we have driver manager, static with a class. We do not want that one, thank you. Okay, so let me just create this driver manager. And let's create the get method. Oops. Return null for just now, that's fine. Then let's do some work. So I'm going to driver.get. Let's go to HTTP. Let's do the basic web page.html. Then I will assert that the driver.get title is basic web page title. Let's bring in these classes. And then we'll have to driver.quit. because I'm going to create a very, very simple driver manager that just instantiates one and passes it back. Now if I run that now, it will fail because our get method, oops, wrong one. Our get method doesn't do anything, it just returns null. So there's no point running that test and have it fail because I know it's going to fail. So let's just return new Firefox driver. Now what I'm doing here is kind of test driven, kind of not, because I'm not driving it through unit tests. I'm driving these classes based on the needs of the functional tests, but I'm only writing as much as I need. So if I run that now, it should create a Firefox driver and pass. Let's run it and see. And this is really how you write your driver managers in the real world. You will write something to meet the needs of what you're doing at the moment. You will go no further. You will not attempt to build a framework. You will just write the classes that meet the needs that you need now. Great, so that passed. So now let's create another test. Now I'm going to do something really horrible and copy and paste this. I'm going to say create a default driver. I want a default. So if I haven't set the system property correctly, then I will get a default back. So in order to create a default, I do not have to set the system property. I would just call driver.get. Then I will get a browser back and I can quit. Now I can start to see some repeated code here. So I am going to move this driver.quit into an @after method. In order to support that, I need to make driver a field. So let's do that. Now I'm doing this just fast and hacky. I don't need any of these quits in here. Now, all of these are going to repeat through every test that I do, so I'm going to just create I'm going to call it that horrible name. In fact, everything is going to do a driver.driver.manager.get. So I'm going to throw everything into there. So that test is just going to do that. And this test is going to set a system property before we do that. Now obviously, in terms of what we're testing, these assertions are not good enough because I'm not asserting for a Firefox driver. I'm going to be visually watching for a Firefox driver. So these tests aren't as good as they could be, but they're good enough for the purposes of illustrating how we create a driver manager. Or I think so. If you don't agree, you can write off to your MP and complain. So there we have a property being set, run the test. But what we don't have yet is a default driver in order to distinguish it between a Firefox driver, because all we have is a single, keep doing the wrong one, all we have is a single instantiation in here. So let's introduce some concepts into the manager now. So what we have to do is check for the system property. So if and we have said Selenium to basics.driver. So if it's got that key, then let's say we're going to use the value that's in there. Now it's awfully tempting to just copy and paste that. So let's refactor that out into a constant. Let's call it Selenium 2 Basics Driver. That will be fine. And let's reuse that. This will be a string. Now I'm going to want to use it outside of this. So let's declare this as a variable out here. Now I basically want to do something based on the browser to use. Now I can tell in advance there's going to be a few of these, so I'm not going to stick an if in with a bunch of nested ifs. I'm going to do a switch statement. Again, one of the things that's interesting is if you remember back to the test code that was in the Selenium, the way they avoided the use of a switch was by having the different supplier objects and having the browser capabilities return one of those, and then the supplier returning the actual instantiation of the driver itself. So they moved the switch out into the polymorphism around the interfaces and having each of the objects do that. So that would be an additional refactoring to do if we really wanted. But I'm going to keep this simple. I'm going to say, in case it's Firefox, then otherwise, let's return, let's say a new HtmlUnitDriver. Okay, so now if I run default driver, if we've done that right, or if I've done that right, I can't blame you for this. If I've done that right, test runs, asserts, we saw nothing, great. Create Firefox driver should still work. Great, and that closed it now. I don't like this now because I've introduced a risk where I might mistype that when the driver manager itself is using a different one. So I'm going to say driver manager dot Selenium 2 Basics driver. So there I'm using the same property that we're using in the driver manager, and we should be okay. So now what should we do? So we've got one for default, we've got one for Firefox. Let's create one for Opera. So in order to make this work, I need to go in here and add the Opera case. Now, theoretically, each one of these constants should be a constant, possibly as an enum, push it in. I'm not going to go that far at the moment, but you can see that that's essentially what I did in the driver that I created. I created an enum for each of these browsers so that I wouldn't have to type in these text strings all the time, and I wasn't likely to mess them up in one place and put in Opera with a capital O in one place and an undercase O in another later on. And let's fix that typo. Okay, so now we have one for Opera, now we have one for Firefox, now we have one for the default being HtmlUnitDriver. If I run the Opera one, we should see Opera. Okay, now what I'm quickly going to do is just double check that the default does act as a default. So default was HtmlUnitDriver. Now I'm going to turn it into Opera driver. Let's run the default. I mean, I'm only doing this because I am paranoid and I haven't got enough tests in place to tell me that the correct browser is running. There we go, so the default is Opera. But now that the default is Opera, I don't have a way of creating an HtmlUnitDriver, so let's fix that. So I want to return a new HtmlUnitDriver. Now you can see all of these are very basic. There's no capabilities in use here. That's an extension we would have to do if we want to create things this way. I'm just doing the absolute basics for the test that we're doing. And we would grow this as the needs of our tests change. So we set the property HtmlUnit, and let's see if that works. Great. Let's set the default back to HtmlUnitDriver. And I don't think there's really anything else we have to do in here. And what about in here? That looks okay. So the only thing that I would really necessarily want to change at the moment is this part here. That would be an additional refactoring that seems a valid thing to do at the moment. And what I might even decide to do is move all this onto the driver manager itself. Maybe have driver manager.force and then the browser, Firefox, and then have the system properties set in, or driver manager.default, and pretend it's a default even though it's not. I might want to do something like that rather than set the property in, but at the moment this is fine. It's coming in from the system properties. And remember, I haven't done anything to read in local properties or anything like that. And the way I've got around that is just by having a default. So if no environment variable is set up, it will just use the default one in here. So let's run all those tests and we should see them all pass with flying colors and the different browsers come up. So that's very simple, but even at the moment, with what little I've done here, this gives me the ability, if I'm using tests that are using Driver Manager, this one here, I could put that into continuous integration. I could have Hudson set this property and then rerun the same tests, but they will run through different browsers. It's a very, very simple way of hooking this into the continuous integration process. So hopefully you did something similar. Hopefully you did something even fancier, but this is enough to meet the terms of the exercise. Now a quick recap for those of you that didn't fancy sitting through my coding exercise there. I'm just going to run through the important points here. So we have a driver manager that meets the basics of the test. It does no more than the tests require. It doesn't do anything fancy. We didn't need any properties files, so they're not there. We don't need any capabilities, so they're not there. We've only used the browsers that we've got in the tests. We haven't refactored beyond that. Now there's refactoring that we could still do. I could move these out into an enum or another object. That would make this easier to read. If I wanted, I could set this elsewhere, but this is actually pretty good because it's saying for this particular test we're going to run it in the properties. I could move this out so we don't have a switch statement, and instead we instantiate a particular object and call it a single time. So for a browser supplier object or something like that. But what's important here is that this is the basics that we need to get going. I can put this into continuous integration and call it from a system property, and we can control it from within the tests, and we have a default for when everything goes wrong. Now I could manage this, the quit. I could decide I don't want to do this quit in the test. This is not important for my test, the quit. I basically just want to say, get me a driver, start doing some work. Use that driver. Just get me a driver, reuse it if we want. Then I might decide to move this driver.quit into the manager in the shutdown hook that we have in the driver class. But I would do that when I have more tests. As soon as I have more tests, and as soon as I see that reusing browsers will lead to a speed improvement, then I will do that refactoring. But I'm not going to refactor in advance. This might be the only test we ever have time to write. We might do no more automation than this. In which case, we wouldn't do that refactoring, because there's no value in it. But as soon as I add another test class, I can pretty much guarantee there's going to be value in moving this quit out so that we reuse the browser. Now really, I'm labouring this point simply because it's too easy to build frameworks. What we really want to do are grow the abstraction layers based on the needs that we have. Now we can see we don't have any capabilities. We don't have remote driver in here. All the browsers are eventually going to start using capabilities as their default control mechanism. We can't support that in here. We will have to find a way of doing that at some point in time. For the moment, this is good enough and we'll grow it. One thing people always ask about, and I rarely do in production, is taking screenshots. But we're going to cover that now. Screenshots is pretty simple. What we do is we cast the driver down to a TakesScreenshot object. The actual interface for taking screenshots is not built into the WebDriver, but you can see that the remote WebDriver itself usually implements it. And we have one method on that object, TakesScreenshot, and it's the getScreenshotAs method. Now it takes an output type, which is an enum, as the argument, and we can say getScreenshotAs file, or getScreenshotAs base64, or getScreenshotAs bytes. File will create a temp file that we can access. So that's good if we're testing locally. Base64 will return a string in base64 format, because a file is a binary object, which we can then use. So if you're working remotely, getting a base64 string back or an array of bytes is useful, because then you can write it locally even though it's come from a remote server. Now we've got two ways of checking whether the driver that we're using can actually take screenshots. Now we can check if we can take screenshots by using the has capabilities interface. So if we cast the driver to has capabilities, then we can use get capabilities and check if it does the capability for take screenshot. That's what the is method is there for. That's an easy way of doing it, or we can just try and cast it directly to take screenshot, and if it can't, it will throw a class cast exception. Now it's your choice which one you use. So we'll look at this in code now. That's just a quick overview. Essentially, we cast to take screenshot, then we have a single method getScreenshotAs. We can use has capabilities in order to check whether the capability is present, or just cast and catch the exception. Okay, I'm going to create a very simple test here to demonstrate the screenshots. So here I'm starting up a new driver. We're going to get a page. Then what I will do is I will cast that driver to take screenshot. I'm going to call this snapper equals, and then we want to cast the driver down to take screenshot. Now on snapper we have the get screenshots as method. So I'm going to say get screenshot as, and let's save it to a file, output type file. Since that's a file, we better create a field to store that in. So I'm going to call that temp screenshot, and let's set that up. Local variable, and it should be a file. There it is. So now we're going to a site, we're casting the driver down to take screenshot, then we're taking the screenshot into a temporary file. That would be good enough to demonstrate this, but what we'll do is I will just show you that it does put it out to a temporary screenshot. So let's print the temp screenshot path name. Then because it's a temporary file, we really want to control that screenshot and use it as part of our test reporting or whatever else, the other reason that we've taken the screenshot. So I'm going to say, let's create a screenshot directory for this. I'm going to store that just very quickly on my C drive. We better just make sure that that directory exists. Then what I will want to do is I will want to create a file to move that screenshot into. So in this directory, I want a file called... Now typically I would create this file name randomly, and I'll show you that in one of the examples we walk through later on. Then I want to move that temporary file. So we want to move the temp screenshot into this new my screenshot. Now what we can do is just double check that that file is not empty. Check that it works. So we want to say is greater than, oops, not great there, greater than, and that'll be a long. So we want to assert that is greater than. And what we'll do, just to demonstrate that it's taken this, let's open that in the browser. Because we've already got a browser, we know that browsers can open image files. So if I just say file : / and then add on the my screenshot, the one that we just created, then that should open it up in the browser as well. So now, if I stick debugs on here so we can see this as it goes through. Okay, so let me debug this test. So there's the page we're going to take a screenshot of. So this is basically saying, let's create the TakesScreenshot, which it has done in a temporary file. So that takes a little bit of time. Good, no errors. So now if I go onto the console and print that out, you can see that it's gone into a temporary folder, and it's a PNG file. That's why I made it PNG in the test. Now I want to create a ctemp screenshots directory, so let's just double check that that does not exist. cd screenshots, there's no directory called that, so let's make that. Right, so now I'm in the screenshots and that is empty. So what we'll do now is I'll create a new file to store that in. Now you can see here that that hasn't created that file yet, which is good news because otherwise we might not be able to overwrite it. So then let's move the file in there. And we can see that there is now a go to page screen file in there. And the length is not 0, so we're expecting this to path. Then if I just open that in the browser, here's what the browser currently displays. We're at seleniumsimplified.com. Let me open that local file. And that would just let us double check that the screenshot's what we expect. So there's the PNG file. This is the full page. If I zoom in, now we're seeing exactly what we saw last time, but this is a PNG locally that we're viewing. So I can zoom in and out of that. So that's pretty much how you take screenshots, shown live, and I'll walk you through some of the other tests that we've got around this in just a second. So your screenshot exercises are, first of all, check that you can take a screenshot. So create a Firefox driver, then use the get capabilities to check that you can create a screenshot. Then create another test which just casts it directly. Wrap a try catch around it and catch a class cast exception. You shouldn't get one with the Firefox driver. Then create another 2 tests where you use an HtmlUnitDriver. This time use get capabilities, and you should not be able to create a screenshot. Then when you wrap it with a try catch, you should get a class cast exception. So these are really just 4 tests, 2 which can create, 2 which can't, and use the 2 different mechanisms, one with the get capabilities and one with wrapping it with try catch. And you can decide which one you like best for going forward in the future. Next up, I want you to, in these tests, first of all, make sure that your driver has the capability to take a screenshot, because you may decide later on to instantiate all the different drivers and see which ones can take screenshots and which can't. Then I want you to save the screenshot to a file with a random name in a location that you are controlling. Then create the base64 string and then save that to a file of your choosing with a random name. Then save it with a byte to a file with a random name. Now I've put some hints in there for those of you that may not know Java as well. You may have to do some Google searching to figure out how on earth do I work with base64 strings, how on earth do I decode them, how on earth do I write them out to files. I've put some hints on screen to help you, but again, we're putting this forward without showing you how to do it because it's Java, not WebDriver, and you have to learn how to look for this information when you don't know it. So give it your best shot. When we come back, I'll run through the tests that I've written fairly quickly, and then we can move on to something else. So the first exercise involved looking at the capabilities. So I have created a set of tests called Can We Take Screenshots test. And in the first one, I am using my helper again to create a Firefox driver. I'm going off to a website, my SeleniumSimplified.com website. Now this is the answer to the exercise. So to check with capabilities, I've cast the driver to has capabilities. Then you can see that we have the get capabilities method, which returns a capabilities object. Then on the capabilities object, I can say is, then give it a capability name, and it will tell me is that capability present or not. I can get all the capabilities as a map of strings. Then I can get the browser name. I can get an actual capability, return that platform version. The is JavaScript enabled is really there for HtmlUnit, but it may work on the other browsers. Typically you just pass in the capability as it is, and you can see we've got a capability type object that has come from, there it is, the remote Selenium package. And if I have a look here, you can see that we have, does it support me getting the browser name, taking screenshots, yada yada yada. You can have a look through and see what capabilities we can ask for with the remote driver. Now these are basically there for when we set up a remote driver. We can set up desired capabilities, or we can set up must-have capabilities. This is what we'll use, but we can use it here to check for the capability take screenshot. So I'm casting the driver that has capabilities, getting the capabilities, and checking if the take screenshot is one of those capabilities. Then I'm basically outputting it to a file and checking that the file is written. So can we take a screenshot exception style? So again, I'm creating a Firefox driver. Here I'm casting the driver directly down to take screenshot. I've wrapped it in a try catch block where I catch a class cast exception. Now in this particular test, because I'm expecting the Firefox driver to cast perfectly well, in my catch block I put a fail clause. So if when I cast a Firefox driver to take screenshot, if I cannot to do that, then this test will fail, because I'm expecting to be able to do that and to write a screenshot. For the HtmlUnitDriver, what I'm doing here is casting the driver down to has capabilities, then saying get capabilities, is screenshot enabled, and in here I'm saying if this returns with a true, if HtmlUnit now does take screenshots, this test will fail. Then you can see for the HtmlUnit with the try catch block, I've cast it directly down to a take screenshot, and if it moves on to the next line, I put in a fail clause because I'm not expecting this cast to happen correctly, so it would fail. I'm expecting that when I do this, a class cast exception will be thrown, and then I will just print out the stack trace. So that's the can we take screenshots, checking the capabilities through the casting down to has capabilities, and also wrapping it in a try catch block to catch the class cast exception. Now you get to choose in your tests as you go forward when you're using screenshots which one of these is most appropriate for your needs. So the next exercise was to use the screenshots, the different type where you can get file, base64 or byte. I'm just going to run these tests. The reason I'm going to do that, normally we wouldn't do that, but you can see over here I have this resources folder. When these tests run, they will create a temp screenshots folder in here, and they will write these screenshots out. So I'm just going to show you these tests so that we can see that the actual files are output. So there's the temp screenshots directory being created, and we have our first file in there. And there's our second file, and you can see that I have named them based on the test. So the first one is type file, second one base64. And then I have a random string being put in there to help make the image unique. And there we go. So all three of my tests passed, and I have 3 images out here. Now if I double click this in IntelliJ, IntelliJ should be able to open up the image that I can check. And there we go. IntelliJ is letting me view this PNG file. So let's have a look at these tests. So the first test I have in the persist screenshots test class is persist output type file. Now again, I'm just creating a driver. I'm using my driver manager to do that. I'm creating a Firefox driver. I check capabilities, that the capability take screenshot is present. Then I take the screenshot as an output type file. I'm just checking the length of the temp file to make sure it did write one. And this is where I'm controlling the file. So all my screenshots are going to go in a temp directory for screenshots. So I've wrapped that up into a local method. Then I create a new file name for it. So this one is persist output type file. Then I generate a random date, well, I generate the current date, but I format it in a string to make the file name unique. And you can see here that because this is an actual file that is returned back, I'm pretty sure it's going to be a PNG, but I'm not taking that chance, so I'm going to get the extension from the temporary file name and use that as the extension on my new file name. And again, that's a local method. And we'll have a look at that in just a second. So then I do what you'd expect. I create a new location for the file to move into. I move it, then I assert that the new one is not 0. I could assert that it's the same length, but that's pointless because then I'd just be checking the fileutils.moveFile method. So hopefully you did something similar for your persist output type file name. Let's have a look at the create directory. Now the only reason I've put this in a method is that it gets quite big. And I'm basically saying, get me the current user directory, which because we were in the IDE will give me the root of the projects here. Then I'm saying go into /source/test/resources, and the reason I'm putting these %s in here is just in case I ever run this on Linux or Mac, I can get the appropriate operating system file separator and stick that in my string. So source test resources, temp screenshots. Now temp screenshots didn't exist when we started, so I first of all check if the directory exists. If the directory exists but is not a directory, then I fail the test straight off because I don't want to bother trying to debug this if I'm trying to write to an actual file instead of a directory. If it doesn't exist, then I make it exist by calling the makeDirs directory. Then the only other thing you saw was the get extension. Now this is not a robust method, and all it really does is say, starting from the end of the string, find the dot, then give me everything after that dot to give me the extension. That will work fine on Windows and the various ways we're using this, but it's not a particularly robust method. So then comes on to the base64. Now all these tests are pretty much the same. They create the driver, they check for the capability, they create the directory, they create a file name with the string. The only difference is going to be in how we create that file. So when it's an actual file coming back, all I do is move it into the correct location. When it's base64, I have to decode it first into a byte array. Then I can use the file output stream to write that byte array into the location that we're looking for. So there's nothing really complicated in there. I create a new file, I use that as the file output stream location, then I write the bytes that have come back from decoding the base64, then I flush that file to make sure that it's finished. Now you can see here that because I'm converting it into a byte array here with the decode, you're going to pretty much expect the as bytes method to be pretty much the same as this, but not have these lines. And that's almost exactly what happens. So I can check capabilities. So for bytes, we make sure that we output type bytes, set up the directories in the file as before, create the file location, then simply output that byte array that comes back from get screenshots as into the file output stream that we've created. So hopefully you did something very similar. There's nothing that complicated in there. But remember, we use the output type file when we're running locally. When we're running with a remote WebDriver, we want to use either base64 or bytes. And the reason you would choose between base64 or bytes is more in terms of whether you want to do any processing on that image beforehand.